Okay, can you see my screen now?
Yes.
Okay, perfect. Okay, after the semana I, our group is this group here, okay? After the semana I, we have a new day to teach, okay? It's on Monday, okay? You decrease the number of class with the Luis Yelps and start to have class with me on Monday, okay? Beginning of Monday. For these two classes here, my plan is to have meeting with the groups, okay? And in these meetings, we realize the planning, discuss the things about the project, okay? It's not, my plan is not to teach, maybe explain some technology to work in the project, but the idea here is to work in the project, okay? And on Wednesday, you continue to have class, the common class that you had now, okay? But we start to have this class here on Monday. So, and what I would like to, what you need to have done to the first meeting, okay? Again, you go, you have this file here, the function and non-function requirements, okay? What I expect that you do is go to the Jira, okay? Create the project page if you don't create it yet. In the project page, the capital one of the requirement report, you copy and paste inside, okay? And the second part is the function and function requirements. You copy the information that I have here, okay? It's the first thing. The second thing is you recheck your user store and check if it's continued to be right with these new requirements, okay? I believe it is, okay? But I would like to that you make a double check and confirm that you, what I believe will happen. Maybe you have user requirements, sorry, user stores that does not have any more requirements, okay? Because what I did here, I tried to reduce the number of requirements to be possible that you develop the project in the time that you have. Okay? So for the next meeting on Monday, in the Monday after the Semana I would like to see the Jira with the project page and the user store updated, okay, with these requirements, not the requirement that you wrote. Did you understand?
Yes.
Okay. Again, the idea here is not to complicate things, but it's to simplify the development of project because you don't have a lot of time, and the project is the idea is not to be a very hard project, but it's a project that you can work in the all things that you study here during our course. Okay. Okay. Any questions? No? Okay, perfect. So today we start a new topic, okay? We back to the IoT, okay? What you study here, okay? We enter here, and arquitetura e desenho de redes de IoT, okay? It's the topic that we study today. In this page here, the canvas page, you have the file in English, the file in Spanish, the first file, and two files, okay, in the English and the Spanish, is the topic that we study today. This class is an introduction class, okay, about to study the IoT architecture or IoT, anything in IoT, you need to have some idea about what is a network, okay? And the network course is ahead, I believe, okay? It's not, you didn't have class about network, okay? It's the reason that before we start to work in IoT, will provide some insights about what's network, the main concepts inside the network. It's important to understand that you didn't, after this class, you have only a very short idea about his network. There are a lot of other things, okay? For example, others, routing, this protocol stack. There are a lot of other things that you need to study about networking that we didn't study here. We don't study here, okay? The idea here is only to introduce and to provide the concept that is required to work in IoT, okay? The first thing is, again, if you have any question, interrupt me that immediately and make your question, okay? Don't need to wait or please, if you send a message in the chat with your question or if everything, and I didn't answer you, it's because I didn't see, okay? And please stop me. Okay, Professor, I sent a message in Slack. Okay, I will stop and see your message and answer, okay? So first, what is a network? A network is a group of device, okay? Not only computers, the computer is the best definition, but the current definitions is a group of device that is connected, okay? Device can be computer, smartphone, refrigerators, cars, air conditioner, lamps, and others, okay? Anything that you have an IP can be in a network, okay? The main reason to have a network is to enable the communication and collaboration between users. It's amazing because today you do a lot of different things in the user network. It's impossible to live without user network, okay? For example, the social media to stream, video stream, for example, Amazon Prime or Netflix or What TV, everything is in network. But in the past, I remember the first network that I worked is to share a printer. It's 30 years ago. 30 years ago, I installed the first network in my life. And the main reason to use this network is to share a printer. Today, I believe there are a lot of you that you put the printer in your house and don't know nothing, just install, and when you need to connect, you to next click, next finish in the Windows, and don't know nothing about the how to share and something like that. But in the past, to share a printer is a very specialized word, okay? You need to learn a lot how to define how to share a printer. It's not easy like today. But there are different types of network, okay? In this picture, you have 4. You have a personal area network. It's a very small network that you connect personal device. Like, for example, I have a smartwatch, and my smartwatch is connected with my cell phone and the internet through a personal area network between my smartphone and my smartwatch, okay? It's a type of network. The other one is the local area network. The local area network is a small network, again, but it's not so small. For example, in your house, you have probably, if you have a router, you have a local area network, a wireless local area network, okay? In some domains, for example, the smart grid, the utilities domain, the local area network receive another name, is the home area network, is the network of your home, okay? This difference, the name difference between local area network and the home area network is because with the smart house, for example, the network that you have, for example, in the Metro City campus is a local area network. However, it's a local area network big, for example, hundreds or 200, 300 of computers inside. And the idea is to separate this type of network with the home, where you have 10, a lot of devices, smart device, but you have computers, you have only 10, 3, 4, 5 computers inside the network, okay? You have the metropolitan area network. Things in this situation, you have the city manager, okay? For example, things that the Monterey has in Mexico City 2 or 3 campus, okay? For example, has the one place has one build, another place in another neighborhood has other builds, and another place has another build, okay? And you need to connect these 3 builds, okay? It's not a local area network because you use a different technology. It's a metropolitan area network. It's the network that connects cities, okay, or metropolitan areas. And finally, you have the wide area network. The wide area network is the internet, but not only the internet. Is when you, for example, things in the technological de Monterey, the university that has campus broad in the Mexico, okay, in the Mexico country, and to connect all of these campus, you need a wide area network, a big network that connects a very far place. So I will explain one by one. The first one is the local area network, okay? It's a computer network that can interconnect computers if a limited area, okay? For example, printers, servers, computers, TV, cell phone, okay? Systems are close to each other, okay? Close is not beside, okay? Close is in a kilometer distance, okay? Organization often have several lanes, local area network. For example, in the Mexico City campus, you have at least 1, 2, 3, 4 local area network installed in the campus. For example, the students network, the professors network, the HR network, the financial network is network inside the local network, the campus network, okay? It's containing one officer or building. What is the, okay. The next level is the metropolitan area network. The metropolitan area network, as I said, interconnects computers and users in a region with the size is close to a city, okay? Think this example here. You have an office building, residential area, government building, university campus. You have a different buildings in different places, but in the same city. You connect everybody using a metropolitan area network. An important thing that separate one of the other type is the technology. For example, the local area network today use most of the time wireless connection, okay, like Wi-Fi. In some cases, use cable, but metallic cable, okay, in this type of network. The metropolitan area network, a lot of time, use a different type of wireless connection. For example, WiMAX technology, or using fiber, okay? A long time ago, we built the metropolitan area network of Manaus City, okay? It's a very, very big network and uses a ring with fiber, okay? It's a very high-speed technology network that you share not only information, but videos, phone calls using optical ring, okay, technology. Why the area network is a large computer network that connects groups of computers over large distance. In other words, connects different metropolitan area network, different LANs, but located in the different cities. For example, think this example. You have the Paris, the Washington DC, Mexico City, and New York. You connect everybody through one. Okay. One example of one is the internet. Finally, you have the personal area network. It is in the last because it's the newest one. Okay. A personal area network, or PAN, is a computer network for interconnecting electronic device with an individual personal workspace. Things in this situation, you have a user, the user has smartphones, more than one sometimes, printers, cameras, mouse, smartwatch, and others. It is a type of network, is a very small scale network. It's only to close situation. For example, the range is less than 2 meters, okay? The technology that you can use here, the Zigbee or the Bluetooth or RFID is another one that is very common. Until here, any questions?
No.
You have types of network, but you have also network topology. The network topology describe how the data will transfer inside the network. For example, the network topology describe, for example, how you share the media or how you share the network media. Okay, I will explain better. The network topology is the logical layout of wires and equipment, not only the wires, because you can use wires, okay? And its impact, for example, the network performance, I explained why, the network size, and the network collision detection. I will explain what is collision detection too. Related to network topology, you have the protocols. The protocols is a set of rules, okay? To understand, for example, protocols, a good example is a language. Things in our situation. I speak Portuguese, you speak Spanish, okay? You need to have a set of rules to translate what I say and what you listen, okay? You need to be able that we can communicate, you need to have a group of rules that translate what you say and what I say, okay? And in our case, you use, the protocol that you use is the English, okay? So what is the protocol? Is a language or is a set of rules that define how one device communicates with the other. And the protocol enables that you have different providers, okay? Because the providers develop your product, and when need to talk with another device, you use protocol to define how this communication will happen. The protocols define, for example, what you want to do, okay? The level, the application, for example, the Zoom application has a protocol. The WhatsApp has one protocol. Where are you going? The addressing, the protocols define, for example, the addressing. Addressing is very important because you need to have an address, a unique address to have access in the media or in the environment. How do you get there? The media types, for example, the protocol defines if you can use fiber or using cabling or using, for example, wires. For example, if you depend the protocol that you use, you can use, for example, coaxial cable. And did you get there? For example, acknowledge error checking. The protocols define, for example, how you handle it, how you identify and how you handle it when in the presence of errors in the medium. How the network works. This example here is very, very amazing. Things in the position 1, okay, I get the pointer. Okay. In the position 1, you have the sender, and position 2, you have the receiver. Okay, and how it works. The sender wants to send a message. Are you back because I believe okay, okay. To send a message, oh, sorry. To send a message, you need to break this message in small parts, okay, in small piece of message, and send this piece through the network. And you can use, for example, different routers to send from the sender to receive. In the receive, what you do, you reassemble the data that you disassemble in the origin and reassemble it to provide to the recipient the original message that you send. Okay. The name of this small piece of information, it's packet. Okay. Any questions until here? There are a lot of different types of topology. The first one is the bus topology, okay? The bus topology is a very simple topology that you have a cable and all of nodes is in the same cable, okay? For example, you have here a cable, okay, the media, and all nodes is connected in the media. What is the advantage? It's a setup and a small amount of wire because you need only one cable. The disadvantage is slow and easy to crash. This type of network, it's not, you don't use anymore, okay? But it's very common in the beginning of the network. And the problem is, if you have one part of this cable, it's disconnected, all the network is down, okay? The important thing here is, fix this situation here. When you use one bus only, if you have two people that transmit in the same channel, you have a collision, okay? To understand collision, fix this situation. Think that we start a class and I turn off the lights. You cannot see nothing. You don't have everybody in the same room, a dark room, and you cannot identify who is talking, okay? You only listen. In this room, you don't have you are blind, okay? In this case, think the situation. If there is no professor position, everybody can talk in any time. Okay, in this room, if one people start to talk, everybody in the environment listen. But think in this situation. The only protocol rules that you have is when one guy starts to talk, the other waits to this guy finish to start to talk. Okay? In other words, if you listen something, you cannot talk. You won't talk when the media is quiet. However, if the media, the environment is quiet, and two guys try to start to talk in the same time, what will happen? You lost the information. It's like, for example, if everybody starts to talk today in the session, what will happen is probably I didn't understand, a lot of information is lost because 2 or 3 people talk in the same time. When this situation happens, it's what your name is collision, okay? You have a collision, you lost the information, you lost both information, okay? The protocol defines a second thing. When the collision happens, all nodes in the channel start a temporizer, okay? Starts a timer, okay? And randomly starts a timer and randomly selects an amount of time that you need to wait, okay? When you finish this time, you are able to talk. The problem is, in the second time, you have another guy that starts to talk with you. You generate a second collision. When you generate the second collision, all the nodes need to reset the timer and start again. The problem of this type of topology is the size of this network. Most of the time, the bus topology impacts in the size, because think with me, the number of collisions increase with the number of the node. If you have a so big network that use bus, the probability that you start to talk and don't generate any collision is very low. Okay? Do you understand?
Yes.
To solve this problem, you start to, it was developed the star topology. In the star topology, you have a central point where all nodes send your data, okay? And what happens? You send the data to the central point, this central point redirect the data to the destination. The advantage is to set up more resilience, because if you lost this connection here, you don't lost the network, you lost only this part of the networking only. The problem is when the hub crash, you lost the network. Okay, it's the most common topology. Okay, you have two different types of implementation, three different types of implementation of the StarNet topology. I will explain later this how to do it. The next one is the ring topology. You have a ring, okay, and the most important concept is the token. What is the token? It's like a token when you run, okay, and to talk you need to have the token. You have only one token, okay. What assure that only one people talks in the same time. The problem in this network is it's a slow network because only one guy talks at a time. For example, if you don't have a token, you need to wait your time to receive the token to talk. Okay? But the main advantage is don't have collision in this type of network. And the last one is the mesh, is how the internet works. You have connections between nodes by nodes. You don't have a central point. For example, if you lost this node here, you have backup connections. For example, if you lost this node here, you didn't lose, for example, the communication between with this node, because you can go. If you cannot use this path, you use this one. You can use, for example, this one. For example, this one. Oh, are you close and try again? Okay, things that you lost this node. Okay. You can continue to use this router, this route, or this route, or this route, or this route to acquire the same place. Okay, it's the main advantage. However, it's hard to set up. It's very hard to set up this type of network. And one type of mesh network is in the internet. Okay. Until here, any questions? I'm fast. I'm teaching fast, or it's okay?
It's okay, but teacher, I have a question.
Okay, go ahead.
And what is the best topology to use in all the cases?
It's depend. Okay. Most of the time, in for example, in your house, okay, in the local area network, you use this type of topology. Okay. Oh, sorry. Oh, where is it? The star topology. Okay. For example, in your house, maybe you have an access point, I suppose, to share the internet connection inside your home. Okay. When you use, for example, an access point, you have this type of topology, is a star. But think the situation. You have a access point and you have a repeater. Okay. And the access point and the repeater, you can have a type of star connection, or maybe you have a mixed connection, like a star if a mesh. Okay. Again, the most common topology is the star. Okay, most common is it's what you find in a lot of places. Okay. But for example, the cloud. The cloud is a type of mesh, is a partial mesh topology. Okay. You didn't, for example, the idea of the cloud is, okay, I lost the server one. No problem. You have all the server, you can acquire. The information is not in the server one, is in server one, server two, server three. You can acquire the information, use a different route. Okay. The military networks, for example, the military network use a mesh topology because, for example, you can destroy an aircraft and you need to continue to communicate to accomplish the mission. Okay. And this type of network use a mesh to be more resilient to attack. But again, today, you don't use, for example, bus topology. It's very rare to find a ring topology. You find, for example, in the metropolitan area, you find a ring in a lot of implementation. But the most common is a star, follow the mesh in the one. Okay, the mesh is very common in the one, not the full mesh, but the partial mesh. Did I answer, Ivan?
Yes, teacher. Thank you.
Okay. So again, topology is logic. Okay, it's not exactly the physical thing, because you can, for example, if you use virtual machines, okay, for example, I believe you can already use a virtual machine in your computer to use Linux or other applications. But you can use, for example, virtual machine to implement a very big data center. For example, the data center on the cloud, for example, you have, for example, 10 physical servers, but inside this 10 physical server, you have 1,000 of logical servers, okay? It's exactly the same in the network. You have a physical connection, but inside this physical connection, you have a lot of logic connection, implement a different type of topology. Okay. Now I will start to learn about the network media. Again, this more complex type or implementation of network you study in the network course. Okay, it's not the time to study it here. You don't have time to study it. So network media. You have different types of media to connect nodes. For example, the network media define, for example, if you use fiber or use cable or use wires, what the media will define? Define the speed of the network, okay? Define the security and define the size of network. For example, if you use coaxial cable, the size is very small. The security is good, but the speed is very low. For example, if you use a fiber, your speed is very high, the security is very high, and the size is very high. Okay? The type of media will define these three attributes of the network. For example, the twist pair cabling. Okay? The twist pair cabling is the most common LAN cable. Okay? For example, if you go to the data center in the Monterey, the campus, Mexico City campus, probably in the data center, you'll see a lot of twist pair cabling. okay, a lot. It's very common, okay? It's not common to, for example, to find a connection, for example, the user connection. For the user connection, most of the time they use the wireless, but to connect servers, printers, and others, you use this type of cable. You call them, these technologies, the Cat 5, but now you have the Cat 6 and the Cat 7, okay? Category 6 and Category 7. You study, again, you study about it and the network course. And these technologies, you'll find this 100 base T. The T is the twister. The base is the basic, it's about the modulation you study, but base you understand network, okay? The common network, the simple, the data network, okay? The other network that you don't use base is the other type of networks, okay? And 100 is the amount, is the speed, okay? For example, 100 base T is 100 megabits per second and twist cable. For example, if you have 1,000 base T, what it means is using the twist pair cable, and it's 1,000 megabits per second. 10 base T is 10 megabits per second and use twist pair cable. Okay. The another type of cable is the coaxial cabling. Okay, it's like the cable TV. Okay, I don't know. In Brazil, it's not so common. Yes, it's common because in Brazil you start to replace this type of cabling to fiber. Okay, but you already find this type of cabling in Brazil. I don't know in Mexico, but it's very common to, for example, in the backbone because. Did you see here? It's the center is the cable, okay? It's the place where you pass the information. You have the plastic, and this part here is a shield, metallic shield, and isolator here. But this part here protects this cable to interference, for example. It's amazing. For example, things that you need to install a cable close to the elevator. Elevator is a type of technology that creates a very big, a very powerful, what's the name, is a magnetic field when you pass, okay? It's very common in the past when you have, you use this type, you need to use this type of cable, but this cable don't provide a lot of speed, it's very small speed. And in some cases, the people use the twist pair, okay? For example, to connect computers to other one, for example, one level to other, using this type of cable, okay, twist pair. This pair here, you have a lot of protection to interference, but it's not so good then, for example, to, if you have this cable close to elevator, every time that the elevator move close to the cable, your network is completely disconnected, okay? To avoid this situation, in the past, you use this type of cabling to connect two levels in the building, okay? Again, today is not so useful because the fiber is cheap now, and the fiber does not have any problem in the interference, okay? Because using lights don't use electricity, okay? But the problem is the speed is not good. It's only 10 megabits. The other one is the fiber, okay? The fiber use light to transmitter, like it. You send the light you have in the one point in the border, you have a lighter, and the light is transmitter in the fiber, okay? In this fiber here. The amazing thing, it's very secure, okay? Very, very, very secure way to transmit data. The second one is immune to interference. You don't have interference problem, okay? You can put, for example, in the duct where you have electricity cabling, you can put a fiber there. You don't have any problem because you use light, you don't use electricity. And because using light, you don't have any problem with the electromagnetic interference. But there is a problem. It's hard to work. It's very easy. For example, in my house, the internet in my house, you use the fiber, okay? And I need to take care about where I put the equipment because it's very easy to break the fiber, okay? If you broke the fiber, you lost, and you need to ask again to the guy coming to your house, replace the connection, put a new connection to provide the service. But this type of technology produces a very high speed network. Okay. I believe the final is the wireless. The wireless data is transmitted through the air. Okay. And you use, for example, the local area network, you use the radio waves, and the ones you can use the both case. You can use microwave signals or radio waves. Okay. Today you have technology like the WiMAX, or for example the 5G. You don't use the microwave because microwave you need to send the data in the line. Okay. You have the transmitter in one point, the receiver in another point, and you need to have a line view between the two, the transmitter and receiver. Okay, and you send, for example, the laser. You send the laser to another point. You can use all the type of microwave signs, but today you have a very smart technology using not microwave but use radio waves. For example, WiMAX is one of them. It's very similar than the wireless, okay? The Wi-Fi is very similar. What is changed is the modulation that the WiMAX uses and then the Wi-Fi using another, okay? The good thing is, it's very easy to set up, but it's very hard to secure, okay? You have a lot of problems in the wireless. It's much harder to protect a wireless connection than the cabling connection. So, until here, any question, guys?
No, teacher.
Okay. So, you have different type of device, okay? The first one is the network adapter, okay? The network adapter is the card that you use in your computer. Today, it's amazing. I'm a very old guy who goes to the dinosaurs. I remember when you bought, for example, you bought a notebook, for example, a laptop, you need to buy this card here because the laptop does not come with the wireless, okay? And this card here is a cable card, okay? And this one is a wireless. Today, most of the notebook and the personal computers already comes with this type of network adapter inside the main board. Okay, the main board already comes with this type of card. It's very common to have this type of card in the server. You buy a separate card because performance to provide a very high speed and don't need to share the bus of the computer with the other things. Okay, the integration of the computer with the other things. But it's the network adapter is what you connect the computer to have access to the media, okay, wireless or cable. The network adapter has a unique machine access code, a MAC address. What it means? You need to have an address. It's like your house, okay? It's like your house. To receive information, to receive data in your house, you need to have a name of a street and the number of a house. if you live in the build and the apartment. Okay, you need to have a unique address to enable that you can receive message from the others. Okay, the name of this unique address in the physical level in the hardware is the MAC address. I will explain later better. Okay, I need to explain better the collision domain. A collision domain is a network segment connected by a shared media or through repeaters where simultaneous data transmit collide with one another. Remember the case about the dark room, and you have things that is 3 people, okay, 3 persons, and that need to talk, okay. Every time that 2 guys talks at the same time, you have a collision, and you lost everything that is in the channel. Okay, to avoid the collision domain, we use a protocol, the name is CSMA-CD. Okay, you are learning about it in the network course, but it works like that. You listen the channel. If the channel is available, you send the data. Okay, but if you listen the channel and it's busy, you don't talk nothing. But if you listen the channel is available, you send the data, but in the same time another guy send the data, you have a collision. Okay, and when you have a collision, you launch a timer and wait. Okay, you launch a timer, a random timer, and wait to try to talk again. Okay, it's a very important to understand. First, how the process happens, and the second, what is a collision domain. Any questions about what is a collision domain and about this process here? No?
Okay.
Okay. An important thing, what is the difference between the hub, switch, and bridge? Okay, a hub, all the case is a star topology. Am I correct? All the case is a star topology. But the hub, what is the hub? The hub has one collision domain. What it means? All interface in the hub is in the same domain. It's like the hub is like, for example, okay, think that is a hub, okay? But inside the hub, it's like you have a bus, okay? You have a bus here. And each computer connects in the same bus. Okay, remember the bus topology? A hub implements a bus topology, okay? And a bridge. What you have in the bridge is a little different. You have a bridge, and the bridge has 2 domains, collision domains. What it means? Where is the, okay. In this interface here, you have a collision domain for this one. And this interface here, you have this collision for this one. It's like this picture here. A bridge, okay? It's not like the hub, okay? Computer 1, computer 2, computer 3. In the bridge, remember the bridge has only two interface. Okay, I change the color. Oops. Give me a second. okay? Okay, in the bridge, it's like this thing here. You have the hub here, okay, one bus like here. You have the second bus. And you have a third bus here, okay? And this bus, you only pass data to the blue network, to red network, when the one data that the blue guy send to the red guys. If you don't have the red network talks with packages from the red network to the blue network, or from the blue network to red network, it's this connection here does not exist. Okay, you won't connect this both network when you have data one network to other. Did you understand the difference? Come on, guys.
Yes, teacher.
Yes.
Okay. The last one, again, it's important because you will realize when exercising you need to have these skills, okay? The last one is the switch. The switch is a different. You have multiple collision domains. In the switch, think that you have different computers, okay? The switch has one component, that the name is the backplane. What is a backplane? The backplane is a shared medium, okay? It's like a shared memory, but a very, very, very fast shared memory, okay? It's here inside, okay? What it means? When these guys send a data to this guy here, what happened in the backplane? He creates a connection only when you need to transmit. He did this connection here only when you have data from this one to this one. I send my data, I don't have any more data. You delete the connection. Oh, now this guy send data to this one. Okay, no problem. Okay, you create this connection. I don't have, I send out data, I don't have more data. You delete this connection. Okay, because you have multiple collision domains. How many? How many interfaces this switch has? Okay, and it is the reason that switch is so many fast. You don't have a lot of collision. It's possible to have collisions in the switch? No, because you have multiple domains. Okay, and the reason is the backplane. Okay, the backplane, the backplane. Oops. The backplane, as I said, is a very high speed shared memory. Okay. Any questions? As I said, you need to have a computer address, okay? You need to have an address that enables that you can receive message in the network. Again, the first one is the media access control address, okay, the MAC address. The MAC address is a unique identifier assigned to a network interface, okay? It's the address of the network interface, for example, the card, okay? The idea is, during the development or when you're manufacturing this card, you save the address inside, you print the address in the chip, okay, of the card. It's in the past. Today, you can change the physical address, use commands in this operation system, okay? But the original idea is you never change this address. It's the address of the hardware, okay? And for example, if you have my smartphone has one MAC address, my computer has another MAC address, my smartwatch has another MAC address, okay? This address is used by the physical level, for example, the wires level, the cabling level, okay? and you find the physical address. For example, in the IP config, you can see the physical address here, okay? And IP address. The IP address is a little different. The IP address is a high-level address that is used by the logical application, like the internet, okay? For example, the physical address you can only use the physical address in the local network, okay? If you have, for example, you need to connect address, for example, in the internet, you cannot use MAC address outside your local network, okay? You cannot use. To have an address that you can use outside your network, you has the IP address, okay? The IP address is a unique address that identifies the device on the internet. For example, you have the device here and you want to talk to this guy, okay? You send, your address is 192.168.0.1. You send message to this guy here, 172.162.162.155.1, and you use this path to acquire this guy here, okay? In a sense, IP addresses are identified that allow information to be sent between devices on the network. They contain the location information and make device accessible for the communication. What happens in the IP address is, the IP address inside, when you see, for example, the address like that, 192.168.0.1, you have part of this address in the other parts identify the host, okay? It is what's enabled to use in the internet. You need the address does not, in the MAC address, okay? In the MAC address, you identify only the device. For example, if you have two network interface in your computer, in the both cases you have a MAC address for the first interface and a complete different MAC address to another one, okay? When you have IP, in the same IP, you identify the node and identify the network, okay? In the same address. Finally, you have the router. Router connect two or more local area network. For example, you have the network A, network B, and you have a router that send data between the one network to another, okay? So, before I continue, I will give you a break, 10 minutes break, okay? Now is 11:20. We return 11:30. So, where is the? So, any question, guys? No.
No, teacher.
Okay, we return in 10 minutes. Okay. See you.